Hello friends, welcome to YouTube channel Electronics for You. Friends, in this video I will explain calculation of equivalent resistance. This is our video tutorial part 2. Before this video I have explained the procedure required for the calculation of equivalent resistance and solved some examples of the same. So if you have not seen this video, please you can watch here on the I button, or you can go into description and click on the link to see this video. So let us see this video. This is our example number 5. Find the resistance between terminal A, B. Now look at this. Here the terminals A, B are situated in between these points. So this is somewhat a different problem than our previous problems. So once again I request you to watch our previous video so that you can understand the procedure for solving the examples for the calculation of equivalent resistance. Now look at this. Our first procedure is to identify the nodes. Now in this case you can see here that this is a single wire, so this is a completely a single node, whereas this and this, that is A and B, is the another node. Means there are three different nodes. So this is our node C, which is indicated here with the color blue, and this is our node A, and this one is node B. Now look at this. As this is a single node, we can label it in our step number 2, and this single node can be represented by redrawing the network. Now let us redraw the network by considering that this is our node C, which is exist between A and B. Now the circuit can be redrawn like this. You can see here that this is our C. Okay, so this C, you can consider that this is also C and this is also C, so we can touch it. Okay, and this A can be represented here like this, and this B can be represented like this. Therefore the new circuit will look like this, and this is our new network. Okay, now we have to identify the series and parallel resistances in our step number 4, and to identify this you can move from point A, that is node A, to node C. Now in this case, if you move from this point to this point, you can see that this 3 ohm resistance is in between A and C. Also this 4 ohm resistance is in between node A and C. It means that 3 and 4 ohm resistances are in parallel because they are sharing the common nodes. Similarly, in case of this, if you move from B to C, you can see here that this 5 ohm resistance and this 6 ohm resistances are between B and C. Means 5 ohm and 6 ohm resistances are also in parallel. Okay, so these two resistances, that is 3, 4, and this 5 and 6 ohm resistances are in parallel. Therefore to solve its equivalent resistance, let us write RAC, that is the resistance between A and C, that is 3 and 4 ohm resistances are in parallel. If two resistances are in parallel, we can write here the multiplication in numerator here and addition in the denominator like this, and therefore after solving this we will get 12/7 ohm. So the resistance RAC is equals to 12/7, and the resistance RBC, equivalent resistance between terminal B and C, is 5 multiplied by 6, because 5 and 6 ohm resistances are in parallel, and here it is 5 plus 6, so it is 30 over 11 ohm. You can convert it into fraction also, but let it be right like this so as to solve it further. Okay, now in our step number 5, you can see, you can write this diagram. You can draw this diagram like this. It is our node A, it will remain as it is, and the resistance which is existing between node A and node C. In parallel, generally we do not remove the nodes, and therefore node in between node A and C, the resistance is RAC, that is 12 over 7, and here the resistance is 30 divided by 11. So this is our new circuit, and solving these resistances in series generally the addition will take place, and therefore the equivalent resistance RAB equal to 12 over 7 plus 30 over 11. Now solve it and you will get the resistance RAB, and it will come to be 4.44 ohm up to 2 decimal places. The value of RAB, that is the equivalent resistance between terminal A and B, is equal to 4.44 ohm. So this is our first problem in this case. Now let us move to the next problem, that is example number 6. Find the effective resistance between the points A and B. Now again the point A and B is located here, and we have to find the equivalent resistance between A and B. Note here that in the procedure I had explained that if you want to find the resistance between some points, so this point must be last there up to the end of the problem. Therefore the point A and B, that is nodes A and B, must be here to up to the end of the problem, and at the end we will solve RAB. Now to achieve this, we must solve this network from this side, because nodes A and B are located here. Therefore we will solve it from this terminal, that is we will solve these 3 ohm resistances first. Now as per our procedure, let us find the nodes first, and here these are our different nodes. This is a single node, then this will be the second, third, fourth, and this is a single node which is already A, and this is the last node which is B. Means we can label these nodes. Now in step 2 we will label these nodes, and we got the nodes as C, D, E, F like this. Now let us solve the problem. Now you can see here that this 3 ohm resistance, that is as we are solving this problem from this terminal, so here you can see that this C, the resistance between CD and the resistance between CA are in series, means that these 3 ohm resistances are in series, and therefore we will solve these 2 resistances, that is 3 plus 3 will be equals to 6. So we can replace this resistance, these 2 resistances by a single resistance. Therefore here R, this is RDB, sorry RDA, or we can say that RAD. Okay, RAD equal to the resistances RCD plus RAC, and it is equals to 3 plus 3 equal to 6 ohm. Now we can replace this with a single resistance of 6 ohm. So you can see here that in between RAD a 6 ohm resistance is existing. Okay, now this is our node D, and this is node A completely. This is node A. Okay, so here you can see that in between A and D a 6 ohm resistance is there, and this is also a 6 ohm resistance. So in our next step, these two resistances, that is 6 ohm resistances, are in parallel. Therefore, solving these two parallel resistance, we will get here R AD. Okay, so these two resistances are 6 ohm resistances. So 6 multiplied by 6 in numerator, 6 plus 6 by in denominator. So we will get it as 3 ohm. Okay, so 3 ohm resistance is now there in between A and D, which will replace these two resistances. So these two resistances are now replaced with a single resistance of 3 ohm. You can see here. Now again we have to solve it from this side itself, so that the points A and B will remain as it is. And you can see here that these 3 ohm resistances now again are in series, and therefore it will get added, that is R DE and R AD will get added, and we will get a single 6 ohm resistance here in this case also. So these two 3 ohm resistances will get added, and we will get a single 6 ohm resistance. Okay, so I will replace these two resistances by a single resistance now, and the circuit will look like this. After redrawing the circuit, you will get these two 6 ohm resistances are in parallel in between point E and A. So in between E and A, this 6 ohm resistance and this 6 ohm resistance are in parallel, and therefore we will solve these two resistances in parallel. Again, same formula will be applicable for the parallel resistances, that is R E A equal to 6 into 6 divided by 6 plus 6, which is equals to 3 ohm. So REA equal to 3 ohm resistance, and therefore the circuit will look like this. Okay, and now you can see here that this 3 ohm resistance, that is we have just calculated, and already a 3 ohm resistance which was there here. Okay, so we have replaced these two resistances with a single 3 ohm resistance, and this is our 3 ohm resistance. So these two resistances are again in series, and after solving these two resistances, we will get a 6 ohm resistance in parallel with FA. So in between this FA resistor FA RFA, this 6 ohm is also in parallel. Now again you can see here that this 6 ohm resistance and this 6 ohm resistance are in between these this point, that is this node, that is RFA. And so solving these two 6 ohm resistances in parallel, again we will get 3 ohm resistance. Okay, so here is the our latest diagram. Now note here that we have to keep node A and node B, and we have to solve it at the end, and therefore we will solve these two resistances now. Now look at this, you have to move from A to B or B to A, and after moving from this point to this point, that is you will get this 3 ohm resistance is connected after this 3 ohm resistance. So these two resistances are in series now, and here is the trick, and it is the most important thing, that these two 3 ohm resistances are in series, and if these two resistances are in series, we can solve it by formula of series resistances, that is R A B equals to this RAF plus RFB, sorry, it should be R, which is equals to 3 plus 3, which equals to 6 ohm resistance. So now this is replaced by a 6 ohm resistance, and And now you can see here that in between node A and B, a 3 ohm resistance and a 6 ohm resistance are in parallel. So these two resistances are now in parallel, and therefore solving these two resistances we will get the final equivalent resistance RA, which is equals to RAB equals to 3 into 6 in numerator and 3 plus 6 in denominator, which is equals to 2 ohm. That is the equivalent resistance between node A and node B is equals to 2 ohm. So in this way we can solve the problem where the resistance is existing between some nodes. Now let us move to the next example, that is example number 7. Here we have to find the resistance between these 2 points. Now note here that I will not write each and every step, that is if resistances are in series and in parallel and so on. So in short I will explain this. Okay, so again the same thing is that here two different conditions are given. Therefore this is our example 7a, where switch S is open. Okay, if this switch is open, then what is the resistance between these 2 points, and if switch S is closed, then what will be the resistance between these 2 nodes. We have to find this. So let us solve the first one, that is when switch S is open. Now if switch S is open, this will look like this. Now as per our procedure we have to identify the node, and if we are going to identify the node, look here that this 6 ohm resistance is there and this 12 ohm resistance is connected to this point, and therefore our nodes will be like this. Okay, so our first node is this one, which is located here. So let it be node C. I am labeling the node also, and this is our node D. So you can see here that if you move from A to B, the node C will be there in between them, and you can see here that this 6 ohm resistance and this 12 ohm resistance uh, are connected one after other. So you can go move like this, and in this case also here this 12 ohm resistance and this 6 ohm resistance is in series. Now if these two resistances are in series, definitely this will get added, that is 6 plus 12 equal to 18. So these two resistances will be replaced by a single resistance, and these two resistances will also be replaced by a single resistance of 18 ohm. Now in between node A and B, these two resistances of 18 ohm will be there, and the diagram will just look like this. Okay, so you can easily see here that these two resistances, that is the resistances exist between node A and node B, and therefore we can say that these two resistances are in parallel, and if the resistances are in parallel, their combination will be in numerator it will get multiplied and denominator it will get added, and therefore RAB equal to 18 multiplied by 18 divided by 18 plus 18. So it is equal to 9 ohm. So our resistance between RAB is 9 ohm when switch S is open. So this is the first condition where we got RAB equal to 9 ohm. Now let us consider that the switch is closed. If switch is closed, it will look like this. Now as the switch S is closed here, this will be a single node. So after labeling the node, after identifying the node, we can say that this is a single node I am marking here, and let us write it as node C. So this is our node C in between A and C and B and which is existing between A and B, and therefore you can see here that now Now if we are moving from this point, that is node A to node C, a 6 ohm resistance will be there, as well as a 12 ohm resistance will be there. This 6 ohm and this 12 ohm resistances, now we can say that these are in parallel. Similarly, if we are moving from B to C, again a 12 ohm resistance and 12 ohm resistance and a 6 ohm resistance are in parallel. So we can write here that these two resistances are in parallel. So after solving it, we will get RAB. Okay, so it will be the resistance between these two nodes. So sorry, RAC. So RAC equal to these two resistances, that is 6 and 12 ohm resistance is in parallel with 6 and 12 ohm combination. So it will be equals to 6 into 12 divided by 18, 3 is 18 and 4. So it is 4 ohm resistance, which is RAC equal to RBC also, because both resistances are having same value, that is 12 and 6 ohm resistances are in parallel. Now we can replace this with a single resistances, this 6 and 12 ohm resistance in between R A and RC in parallel. The nodes will remain as it is, therefore in RAC a 4 ohm resistance will exist there, and also in between B and C a 4 ohm resistance will exist there. Now you can clearly see here that these two resistances are in series because they are connected one after the other, and if two resistances are in series, the equivalent resistance between RAB equal to 4 ohm plus 4 ohm resistance, which is equals to 8 ohm. Therefore in this case, when switch S is closed, the equivalent resistance will be the 8 ohm resistance, RAB. So after solving this, we will get RAB equals to 8 ohm. Now let us solve another problem. It is example number 6. Find the equivalent resistance of the circuit shown in the figure between the points A and B. Again we have to find the resistance between these 2 points. Each resistor has a resistance of 6 ohm of R. Now note that the value is not given, but it is mentioned that all the resistances are having value as R. So as per our step, we will first identify the nodes. So this is our first node after A and B, and this is our another node which is indicated here by red and blue color. Now next step is to label the node. I will label node as D and C like this. Now next one is to solve the resistances. Now note here that we got the circuit like this, which is already here. Now I will mention some resistances here. So this is R, this is R. All the resistances are having same value, so I am mentioning it as R. Now note here that this D and C, in between DC resistance R, and in between CB a resistance R also exists. So if you move from D to B like this, these two resistances will be in parallel. Note here that we have to find the resistance between RAB, and RAB is here, and this A and B must be there up to the last step. At the end you have to find the RAB, therefore you will not start from this point. Okay, you must not start from the this point. These two resistances are also in series, but we will not solve this because in series this point will get lapse. Okay, so this node C will get eliminated here after solving this, and therefore we will not solve this. Okay, so here so so here here we will solve these two resistances, okay, and not these two resistances. So after solving these resistances in series, definitely RDB, that is the resistance between D and B, is 2R because it's R plus R. Now these two resistances will be replaced by a single resistance, just like this. You can also draw parallel like this if you wish. Okay, and it will having value as 2R. Okay, now let me mention here the remaining resistances as R and R. It was also R and R. Okay, so this now you can see again, you can solve these resistances, but you have to skip this point A and B. And now after observing this circuit, you can see here that in between B and D, this 2 ohm resistance and this R ohm resistance are in parallel, because this is existing between this point B and D, and in parallel the node will not get eliminated, therefore node B will not get eliminated. Okay, and therefore we can solve these two resistances which are in parallel. So I can write here RDB. Okay, in between node R, D and B. Okay, again RDB is there. These two resistances, that is R into 2R divided by R plus 2R, sorry, 2R plus, you can write R. Okay, therefore it will be equals to 2R square divided by 3R, and this R and this R will get cancelled, and we will get 2R, we will get 2R over 3. So this is our new resistance in between DB, and therefore our new circuit will look like this. In between D and B, a 2 by 3 R exists. Okay, this is our R ohm resistance, and this is also a R resistance. So here it is A, it's B, and it is our D. Note again that we should solve AB at the end, and therefore if you move from B to A like this from this side, you can see here that this BD and this DA, these two resistances are in series, and after solving these two series resistances we will get addition of this, and therefore R AB here equal to R AD plus R DB, which is equals to R plus 2 by 3 R. Now just solve it. You will get here 3R plus 2R, that is 5R divided by 3. So we will get 5R upon 3 ohm resistance which is existing in between A and B also, and therefore this is one resistance which is existing between A and B, and this is our node A and B also, which is of R. Okay, so 5 by 3 R and this R now in parallel in between A and B, and therefore RAB equal to, again RAB equal to, this is these two resistances are in parallel, so 5 by 3 R multiplied by R divided by addition of these two, that is 5 by 3 R plus R. So just solve it, you will get RAB. So the calculation will look like this. This 3 and this 3 will get cancelled. Similarly, this R and 1 R will get cancelled, and therefore we will get the final answer as 5 by 8 R. So our RAB will be equal to 5 upon 8 R. Further you can convert it into fraction or not. So this is our equivalent resistance RAB. One practice problem is there for you. You have to reduce this network into and find the resistance between node A and node B. Okay, so here try this. I will write the answer at the end, but note that again node A and node B should be there for the up to the end of this problem. So you will solve these parallel resistances first. After that you can solve these parallel resistances. In next step you will solve the combination of these series resistances then. Okay, and later on this these two resistances will in parallel, or you can see that these three resistances are in series. So this one, this will be in series, after that this will be in parallel, and all these three combinations will be in parallel, and after reduction you will get final answer as 1.429 ohm. Therefore the resistance between RAB equal to 1.429 ohm. So try it and check whether you got the answer or not. Thank you. And friends, if you like this video, please subscribe our channel and press the bell icon for notification. And like, comment and share. Thank you.